Let's learn how to 3D print in Fusion 360. My name is Adam James, and like and subscribe for jumping right on in. So as we open Fusion 360, we notice that we're kind of piggybacking off of my previous video from a few days ago, creating that honeycomb structure in Fusion 360. I'm using that same case that we were learning how to make within the CAD software. But I figured this is a good example for us to learn how to use Fusion 360 as a tool not only for CAD design, but some of its other features in its manufacturing workspace. If we look up to the top left here, we'll see design. The design workspace is where I do almost all of my tutorials in CAD development. But there's a lot more to Fusion 360, including generative design, rendering, animation, simulation, manufacturing, and the drawing workspace. I think personally I use the design, drawing, and a little bit of the simulation workspace as well. And then I know a bit about generative design, but it's actually the manufacturing workspace that I probably spend the least amount of time in, specifically due to the fact that when I send off files or I am slicing some of my CAD models in preparation for 3D printing, I do that in Ultimaker Cura. That's just where I originally learned how to do slicing, and they make it so easy and simplistic that I never wanted to learn something else. So these past few days after that honeycomb tutorial video, I went ahead and 3D printed that case, and this was sliced, and the G-code was generated all in Fusion 360. So it went from ideation, design, CAD, and then just changed the workspace and 3D printed this within the Fusion 360 slicer without having to export an STL file. And I think that's the biggest difference, and hopefully the step that I think Fusion 360 is trying to eliminate by incorporating their own slicer within their CAD software, so you don't have to export a separate STL file. So this kind of setup that we're seeing here within Fusion 360 is the example. Of course, it was not printed like this. I can roll up one of my YouTube shorts just as reference to see how it was actually laid out. But let's jump right on into how I would actually set this up. And so if we open our data panel here on the left, we'll see I have all of these models that I've been working with the past few days. I also have this L bracket just for support, so we can see how Fusion 360 generates our support material and slices that. So what I like to do, I like to create a new design. So I'm already in a new design, I won't do that. And as always, we like to save it. So I'll give it a name, just say Fusion 360 3D printing tutorial, and we will save that. And then what you can do is you can import the models that you want to 3D print within this into this assembly. And I think this is the best workflow that I've found throughout the past few days. But again, because I'm relatively new to this, would be open to how you all as my viewers do this maybe as well, and we can hopefully learn together. So I will just import this step file, or this, what is it, phone case honeycomb step. Just insert into current design by right-clicking and hitting insert into current design. That looks good, so we'll hit enter, and then just for an example, we'll have two components, and insert this L bracket in here as well, and hit enter. So we've got two different parts in here, different components, and we'll jump right on it. So let's exit out of the data panel, and we will go to, instead of design, we want to hit manufacture. And there's a lot of different options. You can, depending on your machine, you can do subtraction manufacturing, but today we're going to focus on 3D printing and additive. So the way Fusion works, usually in the toolbars, is a left to right kind of workflow process. If you're new to a manufacturing or one of these workspaces, typically you want to start from left to right, and you'll get there eventually. So we will follow that example and click on Setup. And then you want to work from top to bottom. The UI is something I really respect about Fusion 360. So let's select Machine here. I am using an Ultimaker 3. So we will, let's see if I can remember, Fusion 360 library. It should show up in my, well, it's in my recents, but let's just, for the purpose of this example, actually search it, Ultimaker, and then Ultimaker 3 populates right there. Say you have like a Prusa, you can search Prusa, and there's the Mark III, and you would just select that respectively. So I'm just going to go back to the recents and select that, and it's really cool. It populates kind of the CAD model of the bed that you're going to be using. So cool to see that visual style incorporated. Cura does something very similar. And then you can go into print settings. Print settings, let's see. Local, so we're not actually going to modify print settings yet. For operation type, you get a selection of milling, turning, cutting, or additive. Of course, we're going to keep it at additive. It automatically selected that after I selected a 3D printer, which is great. Arrangement type, I just leave this selected and arrange in 2D. And then the model looks like, let's see if it lets me select this. Yep. And we'll click OK. This says no data. An additive print setting must be selected for additive operations. Let's go back here. Okay, so if we go back to print setting, it wants you to basically select the material and the filament diameter. So I use a 2.85 millimeter nozzle or filament diameter, but typically I think more of a standard diameter filament is 1.75 for maybe Prusas, but double check. You can always double check by looking on the back of your filament, and it'll tell you 1.75 or 2.85 depending on the diameter of the filament that you're using for your 3D printer. So be sure to do that before you select this. And then of course the material that you're using, whether that's an ABS or PLA or a PETG. I will go and just do PLA 2.85. That's what this was printed in, just for kind of concept purposes. So we will select that and we'll click OK. Automatic arrangement, that's okay. All right, so you'll notice right off the bat we're in the red here because we're not within the bounds of the printer bed. So we just did the setup. Now we're going to go to move components. Lets you select components individually, and you can kind of drag them just holding down the left mouse button, and then just hit enter when you find a position that you want to place it. So that looks good, and then we're going to do it one more time for this component as well. Just left click on the component, and you can also rotate them with these kind of bars here by just left click and dragging, and then we can put it in there and just hit enter when you find a location that you think is appropriate. Now, what I have been running into, and I think this is worth calling out, is I'll get these kind of random errors within the Fusion 360 workspace when it looks and appears to be in the bounds of the printer bed. And I think how I've resolved this is I just lift it up a little bit, this model. So if we click on this model again and lift it up, it looks okay. So maybe it's not visually recognizable, but I think what's happening is the bottom part of this CAD model is kind of interfering with the bottom part of the printer bed, so it's not able to actually lay it on the plate. So another way to resolve that is if you hit this place parts on platform, click on the part, and then hit enter. See, now it's on the platform. And you can also just double check that, I guess, with another component if you're not sure. Place parts on platform, hit enter, and it's all good to go. So it looks good. So far, so good. Pretty simplistic. Let's move components again. Kind of rotate this, maybe so we could see the support angles or the supports when it's printing. Enter. Okay, everything looks good to go. Now, one thing I did want to mention is if you do bring in a part, maybe that's of some organic geometry, because not every print is going to be as perfect as this with a flat base of an iPhone as reference and just a block model. So what I did the other day is if we go to move components, let's just bring this off the printer bed a little bit, and let's say we rotate it and hit enter. So we've got something that looks like this, right? Now what's interesting is when I clicked on place parts on platform and then clicked on this and then hit enter, it doesn't actually, so it's different than the way that lay parts flat on platform works within Ultimaker Cura, which I think is kind of disappointing. But I think there is a workaround. You can hit minimize build height, click on the part you're working with, and then hit enter. And then it should kind of lay it flat. This works for the purpose of this example, and would be curious how you all find that works within your workflow for the parts that you're printing, but kind of a workaround to what this is demonstrating from a UI perspective, which appears to be lay flat on platform, but it doesn't actually work that way. So just keep that in mind. It's something I learned. And then we've got solid volume support. So this lets you basically, for each body, basically give it a support volume and an overhead angle for that support. So let's see. If I, for example, want to use the same nozzle for both of these, I have like a dual-headed extruder, right? So same nozzle for both of these, but I want one of them to have supports and the other one not to. That's a little bit harder to achieve in Ultimaker Cura, but this one you can click models to avoid, but I typically don't use that. I just click on the model that I want to use, and it typically works, so that's good. This one, I don't need any supports. This is gonna use a round, and I didn't actually use supports for this top one, but I guess we did see some travel filament there, but I'm not going to put supports for this example. It's okay. And then once you have those supports in there, it seems to work a-okay, and you can kind of visually see what that block looks like. So the next step is we're going to right-click on this PLA 2.85 millimeter and click Edit. And what that brings up is this print setting editor window, and this came up on my other screen, so apologize for that. But this lets you go through all of your extrusion widths, your basically all of the standard print settings that you would see in a traditional slicer. So it gives you your shell settings, how many number of parameters you want, how thick you want that shell to be, your infill settings. This is not a tutorial on how to set up all of your 3D printing settings for slicing. Maybe that's a video if you guys want to leave in the comments down below. I can certainly make one and provide what I use for prototyping or day-to-day slicing setup. But we can just leave this at infill density at 25%. It gives you a lot of cool infill patterns. I don't really care about this, to be quite honest, because it's not visual. But it is kind of cool to see it in the slicer. Oh, look at that. They have honeycomb. Oh, that's kind of funny. But this, like, if you click on flower, you'll actually be able to see, like, flowers populate as you go layer by layer in the simulation process. So we'll leave that at flower so you can actually see that. You can change your infill angle. Print bed adhesion, I typically leave this at skirt, right? You can add a brim, a raft. And then you go into your supports for each extruder. Travel speeds, and all of that good stuff. So we will click OK for the purpose of this example. I think we're just going to use the standards. And then what's actually kind of cool is in Fusion, this gives you kind of a little bit of an ability to do, if anybody's familiar with a program called NetFab, it is an additive manufacturing slicer that gives you way more control and gives you the ability to provide volumetric latticing structures for a particular design, which is a little bit above and beyond what we're doing here. But it gives you a little bit of latticing techniques coming off from the edges, which is kind of cool, which is not something I've done in Fusion 360, but let's see if I have this and I click, let's see, general, anchor density, which is the density of the support, do a small tree structure, and I think you can, all right, solid bar. So let's click OK and see what this generates. So instead of this kind of solid body block, it gives you these little trees as supports to kind of to hold up using printer capable overhang angles. This is probably 45 to replace this support structure, which is just a block. So there could be some unique use cases for that. Would love to hear what you all might use that for. But I would assume if maybe you're trying to shove in a bunch of parts here and maybe you want to take advantage of some of this space, it's kind of a cool feature to recognize that exists. But we're just going to delete that. All right, so now we've got our supports in place. And then at the bottom here, or you can click generate, but I kind of like right-clicking down this tree. You right-click, click generate, and this is basically generating the toolpath for the printer head for whatever printer you have selected. This generation for the toolpath actually stalled at 36.4%, so actually I'd end up just recreating another assembly and importing the monoliths and doing those steps again. So if you do run into that issue, maybe let me know and post on the Autodesk Fusion 360 forum. So now that we have the toolpath created, it'll show, it says 2 hours and 43 minutes, 40 seconds. Looks great. But before we hit this post-process to get our G-code, what we want to do is do simulate additive toolpath. Now, whenever I do this, it says the simulation command needs an additive setup entry to operate on. So I don't know why it does that. Maybe I have to click on this and then click simulate additive toolpath, and that is exactly what you have to do. Okay. Another way to do that is to just click on the toolpath, right-click, and then click on simulate additive toolpath. So learning on the go. All right, so this just lets you see layer by layer how your print is going to look, and look at that, you can even see the flowers for the infill that it's generating for that kind of overhang L bracket over here. Harder to see when it's not a solid density model similar to this kind of honeycomb structure that we're printing over here on the left. But really cool to see. We can even do like a simulation and it'll play layer by layer. I think we can increase the speed. But if you like watching paint dry, then I guess this is what you enjoy doing on your Friday nights. Okay, so we'll stop that, just hit escape to get out of there. And now we are ready to generate some G-code for our 3D printer. So what we will do, just go up here to post-process, and it will bring up this NC program window, and all we're going to do, I just give the name number and the file name, I just label the same, and then enter your location that you want to save it in. So we'll say tutorial 3D printing, and just like that, hit post. Oops, output does not exist because I don't have my Ultimaker 3 thumb drive in, but that's what you do. Make sure your thumb drive is in before you export your G-code, and then take the thumb drive over to your 3D printer and get started. Hope that helped. I think Fusion 360 has a little ways to go within their Fusion 360 slicer, and I hope it becomes a little more seamless in the future so that it does actually alleviate a step and make the workflow a little faster so we don't have to use an external slicer. But not too bad, and super cool to see some of these advanced capabilities in not just a CAD software, right? Feel free to like, comment, and subscribe, and I will catch you in the next one. See ya.